just in case.
Yeah. Well, I think it's always better to have a complete team, right? So you can all answer the questions related to your subject.
Yeah, exactly.
Nice. So I saw also that Attila is going to join.
Yeah, but he will probably join a bit later.
Yeah.
Ah, okay. No worries. So hi everyone. Welcome to the webinar of Visser and Van Baars in collaboration with Felyx. The webinar will start in approximately 4 minutes, or we will start 5:04, just to give other people time to attend as well. So, hi everyone again. The webinar will start in 2 minutes. We will give some people time to attend as well. So in 2 minutes exactly, we will start. So hi everyone, welcome again to the webinar of Felyx and Visser and Van Baars. So thank you all for joining. Well, you most probably know Felyx from the shared electric scooters. Felyx is one of the most fastest growing companies in the Netherlands, founded in 2017 by Quinten Selhorst and Maarten Poot. Still quite a young company, but already expanding internationally. And of course, with that comes a new data environment. Today we have Daan Stroosnier and Mees Stroker. They are going to discuss their new data platform. A little bit of background information about Daan and Mees. Daan is the global head of data and analytics at Felyx, and Mees is a data engineer at Felyx. So they will take us along in their journey of building a new next generation data and analytics platform based on Dataops principles. If you have any questions, please write them down. You can also already send them to us via this chat, and we will answer them at the end of this webinar. For now, I give the floor to Daan and Mees. Good luck, and again, welcome everyone, and enjoy.
Thanks, Noel. Thanks for the introduction. Thanks for being here, and thanks for everybody that's also being here. I'm very happy to share our story with all the participants, hopefully it's you guys will all enjoy it. We definitely enjoy the journey, so that's also what we are going to share with all of you. Maybe it's good to start with a very brief introduction of Felyx. That sort of sets the scene a bit. All right. So, what about Felyx? For those, so hopefully all of you already know what it is about, but for those who don't, maybe it's good to share that a bit, to give a bit more detail. Felyx offers electric scooters that aim to provide the easiest, fastest, and most enjoyable way to get around cities. In the Netherlands, we call it scooters. It's actually e-mopeds, obviously. And it's actually very easy to use. So you just register your account via the app. You have to upload your driver license. You can locate where a vehicle is close by and activate an e-moped via the app, and yeah, enjoy the ride basically. So it's very easy. You pay per minute, 30 cents. You can go from A to B, when you're located again in a service area, you can stop the vehicle and you stop paying basically. So it's a very easy way to get around town. We are expanding quite heavily. We started in 2017, indeed founded by Quinten and Maarten in Amsterdam. But since then, we actually doubled our fleet size every year and expand into new cities, now operating in 11 cities already, across borders. So that's also in Belgium and since recently also in Germany, in Düsseldorf and Hamburg. And there's another city that's coming up pretty soon, and that's Berlin. So we are very excited of that next step. Currently operating 4,000 e-mopeds, but that will increase significantly again with the transition to Berlin as well. We have around 100K active customers on our e-mopeds, so unique customers that use the e-mopeds. So that's a pretty cool milestone. As you see here, there's already been driven 15 million kilometers on our e-mopeds, which is 400 times around the Earth. Yeah, so with all this expanding into new cities and with expanding the fleet size, of course, we also need enthusiastic and entrepreneurial and hands-on people that make this work. So we also are growing our team significantly in all kinds of areas, but of course also in data and analytics. Very briefly, so what problem do we solve as a company? So of course, you might already all know there with the increase of population numbers in all the bigger cities, there are quite some issues when it comes to congestion and pollution and all that kind of stuff. And we think that with our service, we can help in solving that problem. so everything is based on electricity. So all mopeds are fueled by electricity, but also our entire operation is done via electrical vehicles. So there's no emission or pollution or much less noise there. And of course, you can the mopeds are only used when a customer or somebody actually needs to drive from A to B. There's the sharing concept, which really helps to basically limit also the amount of vehicles within a city. And of course, with the setup of e-scooters or e-mopeds, it's very nice that you can sit together on an e-moped. So it's with two people, and of course it uses much less space than, for example, a car. So there could be up to 5 e-mopeds on a parking spot for one car, so to say. So that also really adds to that to solving that problem. Yeah, that about Felyx, and of course with this new concept, basically, there's also a lot of data involved, and that is where the data analytics team comes in. So we have, of course, data that's coming in from the app that is used by our customers. So you can think of the usage of the app. You can think of, in general, information about our customers, of course, but also about promotions, so discounts that we can give them, but also referral bonuses, referral promotions, or that kind of stuff. That is all. We are all able to capture that. Then another important source for us is the e-moped itself, which is basically a big IoT device, where we can capture also a lot of information from. So that's, of course, everything that's related to the trips that our customers are making. So a lot of geospatial or geo information can be extracted. Then about damages, so people, the customers take pictures, for example, from of a damage that is also captured by our data platform, and based on that you can do a lot of cool stuff, of course. And then you have another entity, basically, which is the batteries, and these batteries are, of course, part of the e-moped, but they are actually a separate entity in the sense that they are being swapped once depleted. And these batteries are also basically IT devices that produce a lot of information. Then we have also our own operations people in place. So you can think of customer service agents, or mechanics, or fleet managers. And we actually have a operational system in-house that basically helps them run their operation efficiently. And that in-house operational system also provides a lot of information. So you can think of customer service tickets. You can think of indeed when batteries are depleted, but also about battery swaps. How are they performed by our battery swappers? How is maintenance performed by our mechanics? All that kind of stuff can be done as well. And then last but not least, we also have, of course, some external data. And one of them is very important, and that is weather, because our product is quite impacted by weather, if you can imagine. So you can think of a sunny day, then people really like to go for a ride, and when it's raining, of course, people are less likely to do so. It's also our job to make sure that it's always nice to take a Felyx, but of course there's an impact there, so we need to take it into account. And the same holds for, of course, market information about competitors, for example. That is also something we take into account. Yeah, so with all this data, that is of course very nice to have, but it really adds value to our business if we start leveraging it and bring it into practice and make use of it to make decisions, basically. And well, there are two important aspects where data analytics comes in to add that value, basically, and that is about increasing operational efficiencies, of course, and the other one is about unlocking customer value. So it's either on top line or bottom line that is impacted. So what do I mean with that? For example, based on right behavior and customer information, you can do automated reactivation campaigns. So you can think of predictive models that can predict the probability that a customer is going to churn and not using our product anymore. And you can build marketing tactics on that, for example. Another one is build recommendation engines for the battery swapping operation, where you can build a route recommender for the battery swappers on which vehicle they have to swap at first. We have service areas where you can unlock and lock the e-moped, and of course you can optimize that based on data insights. And then there's indeed taking into account external factors like market dynamics to basically model the supply and demand within our market, and based on that you can prepare the number of CS agents that you want to have for the weekend or for the upcoming busy period. You can think of marketing tactics, you can think of operational efficiencies and all that kind of things. So these are a few examples of that. Then specifically on our department, to do all these very cool stuff that I just described, it's very important that you have good insight into the data and it's actually used by business and business decision making. Hopefully you've seen this picture before. It's not how do you say, it's not designed by me, or I didn't came up with this one. This is basically the Gartner Analytics Continuum, where you see a sort of a maturity curve from descriptive analytics to diagnostic analytics to predictive analytics and prescriptive analytics. And you have to do it all right to make sure you really add value using data. So descriptive is more about what happened, is looking backwardly, and the diagnostic as well. And then the predictive and prescriptive is more about forward looking. So this is an important part of the data analytics team to work on. And of course, the more sophisticated we do it, the less need for sort of human input, and the more automation in your decision making there is. And that is an important part of our job, basically, within Felyx. To do all this, it is of course very important to have data and a very proper data infrastructure, because without that, all of this, these nice predictive models and all those data insights are not possible, basically. Actually, that is what we are going to talk about today. So how do we make sure that all this data, and especially our data infrastructure is in place to do the descriptive analytics, the diagnostic analytics, the predictive analytics, and prescriptive analytics to capture value and create operational efficiencies, basically. And that is actually what Mace is going to talk about and explain you on how we are doing that. We are still on that journey where it has been a lot of fun, and he is going to show you and explain you where we are and what we are doing there. Maybe to finalize from my side, so this is the team that is all helping and enabling this new setup and building this entire new Dataops platform. So we have data engineers in the team, we have data analysts in the team, and data scientists in the team. These are sub-teams, but of course they cooperate very closely. Yeah, these are actually the ones that that doing a great job.
All right, shall I take over? Yeah, so yeah. I will share my own screen because that makes it actually much more easy to go back and forth between the slides. Are you seeing my screen right now?
Yes.
Okay, good. All right, so thanks for the introduction, Dan and Noel. First of all, I don't know if everyone read it in the chat, but if you have any questions regarding the whole presentation piece, show them in the chat because afterwards we will have like 15 minutes for Q&A. So you can post your chat and Noel will give everyone the word and we can answer your questions, hopefully. So maybe in short, yeah, first a bit about my background. So I'm Mr. Roker, data engineer, was and working within Felyx for a little over a year when we actually started with 4 people, and now as you can see the team has grown quite significantly right alongside the company, which has made our work much more fun, first of all, but also you see that now in terms of development we have picked up the velocity quite significantly. So I guess of course that's also really important. Yeah, so let's just start. Oh, yeah. So first a bit about where we come from. So our legacy architecture. So even before we started at Felyx, or I started at Felyx, there was one student before who actually built up the whole architecture back then. And well, to be honest, he did quite an amazing job. He built literally the whole data warehouse back then on his own. But what you could see once we started working there is that it was actually also quite based on an ad hoc basis. So from just unrelated business requests, some part of the application was built, and then for the next request a part was built, and then for the next request, and it sort of became like a conglomerate of all those ad hoc requests. And that of course has led to some issues. One of which is first of all the Postgres scalability. So as the business has now been growing quite a lot, we actually noticed that at some points the performance of Postgres was just not really good anymore. We had to put a lot of time in maintenance. Also, just analytical queries were getting quite slow. So we just said, okay, this is not going to work. Oh, and by the way, before I continue, I forgot to tell you. So if you look on a picture on the right, what you actually see is we have actually 3 main data sources. So on the lower part, you see that we just take, of course, data from APIs and external parties. We also take database snapshots, and we also have like an event queue, which our own application backend system, so which is built in-house, sends events to, and we consume them. And basically then everything is loaded into the data warehouse. and sort of all the ETL jobs, which is also quite important because we're also going to talk about that. And the data warehouse itself were all hosted on Heroku. So yeah, the Postgres scalability was an issue, and we basically said, okay, well, we actually need a more mature and professional system to deal with the amounts of data which we are now getting in. Also, scalability was possible in for sort of the data warehouse application, which was handling all these ETL jobs and pipelines. Basically, the issue was that you could add, so Heroku works with dynos, which are like isolated containers where you put parts of your application in, and you could scale up horizontally by adding more containers if you want, or dynos they're called, or you could scale up vertically, so increase the resources for each dyno. However, they were also you could scale up vertically in sort of in groups. So if you had to scale up, for instance, one dyno to a certain instance, sometimes you had to scale up all your dynos to that instance, which of course was more expensive because you would reach a new dyno instance group. So that meant that, of course, the costs were increasing quite fast. So we were also looking towards a bit more a flexible and more elastic way of scaling up these things. Yeah, also the debugging experience was actually quite poor, in my personal opinion. For instance, I noticed still that we, for instance, at one point when the queries were getting really slow, we're thinking about that actually some read and write operations were using disk space, so they were getting really slow. But we actually the documentation was a bit too poor to help us out how we should eventually go into that virtual machine and look if indeed this was happening or not. But we actually didn't manage, so that was quite bad. And of course that led sometimes to just limited failure handling, which we of course also want to improve. Yeah, one other important part was that so we were getting events from the event queue, so from our own internal backend system, but there was actually no sort of we had some documentation on agreements on if a schema changed for one of these events, what we should do, but that was just documentation. And it actually often happened that we changed something was changed, and once we were consuming it and transforming the data, that we actually noticed that something was really wrong with it, and that all the while this was just running in production, and also there were sort of no integrated tests there, and yeah, there was just no validation on what was being sent to us in the first place. So that was also not really good, and that of course led to just data quality issues, which was quite bad. But I think most importantly, what's really important for this presentation as well is we basically had just wasteful ETL pipelines, by which I mean that, for instance, if we consumed a certain event, transformed it, and stored it, stored the transformed data, that, for instance, after 1 week, we realized, hey, we did something wrong in the transformation, or there was a bug. Well, too bad, because all the source data is gone. So yeah, that was quite bad. So of course we also want to fix this. Well, those are the sort of the issues we are of course try to solve in our new architecture, from which you see an overview on the right. Yeah, maybe good to know is that for this talk we will be focusing mainly on the middle part of this picture. So first of all, of course, the sources with which we load data into our sort of data lake. We'll explain a bit more about that later. And then going upwards to these raw data, clean data, and rich data, and data mart layer. And what we were looking for is, of course, to solve the scalability, and also, yeah, maybe a bit of a buzzword, but the elasticity issues. So this was actually quite solved already by moving our data warehouse to a Snowflake environment, which is helping us out with just coping with greater amounts of data quite easily. So that's really good. And yeah, this is also the next one. Bullet points are, I think, maybe a bit cheesy. So change is the only constant, but it is kind of true, right? So in our sort of in our world, things are developing really fast. New tools are popping up everywhere, better tools, sophisticated languages, etc., etc. And you want to be able to just evolve your whole architecture, your landscape, along with the world which is evolving around you. Which also led to the idea to have like this Unix philosophy. So build up our whole architecture in quite a modular way, and also be able to, if something is outdated or should be removed or can be replaced by something which is better, we can just easily take it out. So what we did also in this whole setup is always think about what the sort of the exit strategy is for implementing a tool. So can we always go back from it? Yeah, that's what we also always had in mind. And also with this Unix philosophy, we mean that we for each module, well, ideally you would have like a really extensive sort of evaluation matrix for all the parts for all your module parts. But that was a bit, of course, we were also under a certain deadline. So what we did do was for each module do a sort of a POC or create an MVP, basically to evaluate what the best option was between two or three options, and select the best one and go with that. So that's why we also have, yeah, I think quite some different technologies all working together. Yeah, so the debugging experience is already, because there's better documentation on everything. We just have much more feel for that at the moment. And quite important is the movement from the ETL system to the ELT system. So basically what we do right now, but I think in the next slide we'll show you a bit more about that, is just all the data we get, we just store the raw data. So we will never lose it. And if we build sort of our data warehouse on top of that, we can always rebuild it or restructure it, but a bit more about that later. But that also gives us just a lot of flexibility and insurance that we will never lose any information. And yeah, also quite important in this presentation, and for us as a data and analytics team, is to provide eventually the company with self-service analytics. For us as a data engineering sub department, this would actually have sort of two layers. First of all, we want to make sure that our data and analytics team is sort of self-service. So we have a lot of analysts, which are quite technical, and also data scientists, of course. And the first layer of being self-service, what we mean with that is that built on top of our data warehouse, we have our sort of our dashboard platform, so our data and analytics platform, and the analyst should quite easily be sort of able to create that whole environment based on the data warehouse, and even within the data warehouse also be able to service themselves and create their own database objects. And what we did for that is basically just choose the right tooling, and we'll also tell you a bit more about the data build tool, so DBT, so which is what they're using right now to create database objects and layers within Snowflake data warehouse. And I will get back to that a bit later. And so that's sort of the first layer of self-service analytics. And of course, in the end, what we want with our data platform, with our dashboards, is that the rest of the company can very easily access that environment and just drill down on dashboards and get all the information they want. So that's sort of the ultimate goal, of course. Yeah, so what kind of data do we actually get into our data lake? Well, it's not like extremely exciting, right? It's not really big data yet, of course. But what you should know is that what's kind of important is we are just having mostly, I would say almost only so streaming event data, which comes in Avro format. Then we have just database snapshots, for which we use a new line delimited JSON files, but also CSV and JSON files. And then, of course, from third-party API calls, we get JSON data, which is, I think, quite easy to understand. What is quite important to know is that we chose the Avro format because we said in the beginning that we had trouble with event schema change management. And what we have now sort of in place is that we run validation on it. And we'll also get back to that a bit later, but just to already inform you on that. And then let me see. Oh yeah, of course, the event data is actually just being processed by sort of, don't know how you would call it. It's actually just a very simple Python application, a piece of software, which we created ourselves just to handle all these events and write them to the data lake. And of course, we have certain jobs running, which take data snapshots from different databases and from third parties APIs. And this is now all being run by Airflow, which is helping us out also quite a lot, because it used to be sort of Celery running in a dyno, but now we have like a complete overview, which is much more manageable. So also this part of the whole scheduling of and orchestrating of all these jobs has improved really quite a lot by using Airflow. So a bit more about the ingestion part. So the data which we get from the data lake from the events is being validated with an Apache Beam pipeline. It makes it possible to just handle lots of data and validate it and write it to Snowflake eventually quite easily. And then we have schema management, which is managed by Liquibase. So when the data gets into Snowflake, so into our data warehouse, of course, what you could do if you have no data is keep your sort of schemas under version control. So just put it into GitHub or something. However, if you have data, of course, it becomes quite different. You want a tool that actually makes sure that you're able to change the schemas incrementally and make sure that nothing breaks when you have data in your data warehouse. And that is what Liquibase is doing for us. That's it. And then maybe a bit about the data model. What we did eventually was create a lot of layers actually in the data warehouse itself to sort of granularly build up the data model. We did it, of course, it's quite obvious to improve the data quality, but what is good to know is talking about sort of the self-service part of it is that we, as data engineers, basically said, well, we want to just hand the analysts and the data scientists sort of a very easy format of the data so that they can really quite easily build themselves sort of the enriched tables and relational tables. And we actually, for our part in the data warehouse, have considered multiple options, one of which was, for instance, Data Vault, but we actually concluded that it was a bit of over-engineering, right? Because we have quite some layers, and just storing the lineage of your data in every table over multiple layers would become like quite heavy, and just felt like it was a bit of an overkill. And eventually we just chose to work with normalized tables, but include some history columns, so that if you create enriched layers based on top of that, it would become quite easy to do so. Maybe the most important bullet point of this slide is that every choice was a bit of a compromise, and we are also not sure yet if we have chosen the best solution, just as actually with other parts maybe, but the most important is here that we are able to, in an agile way, to recreate the whole data structure because we have chosen the right tooling. And that's just most important. We can always, because we always have all the data, very easily recreate this whole pipeline of the data model. So maybe then a bit more about the DBT, so data build tool itself. We use it to manage enriched models and the data mart layer. whereas what's I'm not sure, of course, if anyone is already familiar with it. Probably a few people are already. But what is really nice is just for the analysts, where they normally would just use just simple SQL queries and not have like this developer experience. What Data Build Tool also adds for them is like that you can have version control and testing, and you can also have reusability of your code. So and talk a bit more about that, but all of these sort of things add to the sort of the developer experience or software developer experience of the analyst. And that also means that new buzzword that we sort of now look at them as sort of engineering analyst, so analytics engineering. And what that also basically means is that a lot of tasks which before were done by the data engineers can now be done by the data analyst. So that's also very important, because it sort of spreads the load between our whole team. And and luckily for us, we have like quite technical analysts which are capable of doing this. But as you'll see, Data Build Tool is also quite easy to understand. And what is also so a bit more about Data Build Tool. What actually happens there is everything you do. So you basically are creating eventually your sort of transformation pipeline for your data, and everything is written with just simple SQL select statements. And I'll show you a bit a few code snippets in a second. But basically, what it also does for you is generate documentation sort of out of the box. So you write your files and your tests, etc., and give descriptions to certain models and tests. And what you can actually do then later on is generate your documentation straight out of that, which is just a really nice feature to make it clear to everyone what you're doing, and to also keep track of your own process yourself, of course, as a team. You have different materialization strategies. So what you can create are sort of, for instance, tables, and of course like views. And then you have the ephemeral materialization strategy, which basically means that you're just creating common table expressions, which can be used again in other models of DBT. Then you can have an incremental materialization strategy. This is sort of a bit more of an advanced mode, which basically means that you check if, for instance, for a certain table, there are new records present, and based on that, you can rerun or your DBT code. So you can have sort of a lighter weight approach to your transformation pipeline, because otherwise you would just have to rebuild the whole environment again every time. And you can also write your own materialization strategy, which is, I think, even more advanced, but I've never used that actually. And then, maybe a bit about the ref statements. So as you can see, it's also using Jinja templating, but what ref statements actually do for you is that you, actually under the hood takes care of two things. So first of all, it sort of interpolates the name of the schema. What that actually means is that you can sort of dynamically set your environment. So if you are on development environment, you can just point that out to DBT, or you're in an acceptance or staging environment, or on a production environment. Those things can very easily be changed using these ref statements, or you can easily work with that because of these ref statements. And also it helps DBT understand sort of dependencies between your models. So in your transformation pipeline, there are dependencies. For instance, you create a certain table, and with that, or few tables, and with those tables you recreate another mart, for instance, and then this sort of lineage is automatically recognized by using these ref statements by DBT. And what does that look like? It looks then like this, for instance, for a very simple battery domain. So maybe it's even good to give you a bit of an explanation on Dana, of course, already mentioned it. We're e-moped driven company. So of course, these e-mopeds have batteries inside of them. and well, of course, they get depleted also, and then we have to swap them. And basically, battery swap just means data about when a battery was swapped. But what you can see in here is that eventually on the right, you have created like a mart for the battery domain, and you can really easily track the lineage of your data, of where it comes from. And that is just really good to have an overview of what you're doing. Yeah, done here a code snippet of DBT. So on top, so this is like a model file, so it's a SQL file. And on the top, you can specify your configuration. So for instance, on which schema you're applying this model, give it a name and choose your materialization strategy. And basically what happens then is, yeah, it's basically, as we said, only SQL select statements. So yeah, and this way you can, of course, create your database objects in a very simple way. And what you can see, for instance, it's a select statement. Then you have the from, and then the source keyword, which basically specifies which are your source of your source table. So those are not created with DBT, but you base your DBT tables or materializations based on these source tables. You can easily reference them with the source keyword. And after that, you also have conditional statements. And in this case, the materialized strategy is used because we are looking if a new battery swap event has come into the data. And if so, we want to trigger the DBT script. Maybe another simple example. This is also even more simpler, to be honest. So you can just use common table expressions, write your SQL select statement, and maybe it's good to, oh no, they're basically just the same keywords which are used. But this is just an example of what it looks like. So again, you're creating an enriched layer, you're creating an enriched table, use common table expressions to get your enriched data. For instance, what happens here is, of course, batteries, sort of the battery life cycles is also dependent on how often it was swapped. It will break more easily if it was swapped already a lot of times. So in your enriched layer, you want to be able to know how often a battery was swapped. And that's what we call the cycle counts. And well, as you can see, you can very easily in your enriched schema create a table with which is called battery, where you have your cycle counts per battery. So that's quite easy. Yeah, so actually, just to recap a bit on this. So we've now gone through the source of the data to the data lake, and actually a bit through all the layers. And eventually the analyst will have created the enriched and the data mart layer, and that will make the end users, yeah, of course, quite happy. Don't know how else to say it. Yeah, so who are the end users? So this is, again, from a data engineering perspective, we had sort of, the self-service part was consisting of two layers. So first one sort of internal from our own team, and then for the rest of the company. And this is what our end users, the end users of the data engineers, are building this whole data platform for. And well, we have just analytics translators, which are using an open source dashboarding tool called Metabase to do to build dashboards and to do descriptive and diagnostic analytics. And then we have our analytics engineers, which are building this whole data platform with sort of custom dashboards in R, Shiny, and Dash. And this is also descriptive. And then, of course, we have the data scientists, which use this this whole architecture basically to create their machine learning models in a much more easy way. And oh yeah, of course, yeah, good. So yeah, of course, a little bit about change management. So one of the most actually important factors, of course, of our whole new architecture was just to be flexible. Well, basically, just going to skip the first one, because that basically means we are now, because we're using Airflow and can very easily and have set up everything in quite a flexible manner. It's really, really easy to, and because we're using liquid base, it's really easy to sort of add new domains, data domains to our whole environment and to load them in. But this is also really possible because we are using templating a lot actually in our environment. So for instance, in Airflow DAGs, in DBT as well, you see that there's Jinja templating also in our home charts, which is a bit more advanced, I guess. And I think we are even using custom Jinja templates, but I have not implemented that myself. So I safely left it out of here. If you have any questions about that, I hope we can answer them. But it basically means that we're really, really flexible in switching between, eventually between environments and dynamically creating all of our sort of scripts. And of course the schema change management of the database schema itself is done with liquid base, and this also makes it really easy to just transform your whole data model actually. And one last feature I would really like to highlight is Snowflake zero copy cloning. So this is like a really, really nice feature within Snowflake. So if you're on a dev environment yourself and you want to really test out something on not only the database structure, but on the data itself, Snowflake has this really easy feature which lets you just clone a whole database. Then you can run your changes on it, test it. If it breaks, well, you throw it away. You create a new copy clone. You do it again, and if it then after some changes, and if it then works, well, fine. Then you throw it away again, and you know it's working. And you can also, from a CI/CD pipeline, really use that to create a nice CI/CD pipeline to do automated testing on these clones and on your actual data as well. Let's see. Yeah, so and of course, acknowledgements to this whole team of ours, because almost everyone is involved in now in building this environment, as we mentioned. So, which is, I think, also really cool and also good for your sort of your resource management as a company. So that's really cool. Yeah, and that was it. So thank you for your time. I cannot see how many people there are in the chat, so I hope there are at least as much as there were in the beginning. And if not, no worries. And I think now it's time for questions. So thanks.
Yeah, thanks Dan and Maes for the presentation. I think it was very clear and very interesting, and I think a lot of people found it interesting as well, because I can see that almost everyone is still looking. So now as the time has come for the questions and the answers, of course. For this, not only Dan and Maes are available, also Carolina Londoño, data engineer at Felyx, and Lars van der Ham, a data analyst at Felyx, are available, are here also to answer your questions. I already saw quite a few questions coming by. So let's start with a question coming from Victor. What type of organizations have you used as a potential benchmark for data drivenness?
Yeah, maybe I can answer that. And indeed, the guys, please add. So we of course used a few. So I think that was also another question. So we started this project basically with Maes indeed, and Attila, a freelance data engineer. So he has also brought in quite some experience, also of course from other companies. So that's one. Second, we had some chats with some peers, for example, Picnic, another well-known company when it comes to data. So they were basically one step ahead, or maybe two steps ahead on our journey, and so that really helps, of course, to compare yourself with. And I've worked for 8 years at PwC as a data analytics consultant, so I also had some contacts, of course, from my previous employer, and worked at a lot of clients in a more corporate environment, but that's also a place where you learn on how you should not do things, I guess, and that is also what we took into account here. as well. So.
Yeah, and maybe to add to that, so I mean, for every module, we sort of compared at least, I would say, 2 options, but often more than that. As I also mentioned in the beginning, ideally you would like to evaluate every possible option for your in this case for a module. But I mean, just in terms of time and being pragmatic, we did not do that. So like Dan mentioned, we talked to already people who were a bit further than us from those conversations, and of course our own sort of research on the we sort of picked a few options, and between that we most of the times did an MVP or a POC, and then just decided what to do with it. I hope that answers the question.
Nice. And so I have another question from Peter G. When you switched, how much data have been accumulated in Postgres, and how much was being added each day?
Yeah. Okay. Well, from the top of my head, it's not like insanely much. When I think in the time when I started, it was like in the first few months it was like 30 gigabyte a month or something, so not a lot, but it's becoming much more really fast. In terms of events, for instance, what's also good to know is it wasn't that much because we used ETL, right? Because we are not storing every record which we receive. We are receiving like 1.5 million events each day, and we now say we want to store them. So and our fleet size has doubled and will double even further. But so it also depends on how you're storing your data. So it will become like much more really fast.
Nice. I saw that there's another question from Nick Lammers. Did you get any external help with the switch to the new architecture?
Yeah, so I think I sort of answered that question in the sense that we got external help by having an external or freelance data engineer, which is Attila. But basically we developed everything in-house. There were no consultants involved, or it was not externally built, so to say.
Yeah. And another question from Victor. Regarding from ETL to ELT, have you also looked into other options, such as, for instance, data virtualization?
To be honest, no, because for our use case, using ELT was really suitable. Happy to read into it a bit more. For me, it's also quite new, but no, we didn't do it. We just noticed that what was sort of causing issues for our situation, and that was actually almost solved by just switching to this way of working.
Yeah, so we really approach it from our use case perspective. So what is the first thing that we need to solve? And that's that self-service analytics type of setup. And also, if you look at our data, it's all, well, back then it was really structured data, right? So, and now it becomes also more unstructured data. So then also other techniques come in, of course. But this is really about the structured part.
Okay, clear. Thanks. Let's continue with another question. A question from Khalil Shuru. Why don't you use Looker for data modeling?
Well, I think I'm going to give that to Lars, but
yeah, sure. I can answer this one. Let me first start off by saying that I think Looker is actually a great tool. Why we didn't use it, it basically leads back to one of the first slides that Mace showed, and it's that we try to build our architecture on a Unix philosophy, and it means that we want to have reusable components, and that we also need to have an exit strategy. While Looker is I think, very good at what it does. It's kind of hard to replace it once it no longer fits your needs, because then you not only have to change the way you handle your data modeling, but you also have to change all the presentation or the entire presentation layer that's built on top of it. So we deliberately chose to separate those two. And to be completely honest, the cost aspect of using Looker was also a big factor in this. Because yeah, well, the price tag of using Looker it's just not it's not very small. So
Yes.
I hope that answers your question.
Yeah, thanks, Lars, for your answer. I think it's a clear answer. Let's continue to another question from D9. Is it one big data model or modeled into domain-oriented modeling? Does your model also handles right to be forgotten?
Sorry, could you repeat that?
Yeah, of course. Is it one big data model or modeled into domain-oriented modeling?
I'm not sure if I understand the question. So it will. So eventually we get data, of course, in certain domains, and we store it as such. But eventually it will. Yeah. I'm sorry. I'm not sure if I understand the question.
No worries.
Is it the question regarding how you group your data in certain tables? I'm not sure.
Yes, D9, could you please reformulate your question? Then we can answer that later on.
And well,
Okay,
I can answer the second one because he's also he or she is also asking about the rights to be forgotten.
Yeah.
So that's a very good question. Of course, this is also a top priority for us and also something that is top of our mind. So with this setup, yes, it's quite easy to clear somebody basically or forget him from the data, right? So I'm not saying we have now already fully automated it, but we have set up with this new setup. It's quite easy to to capture that personal data basically.
Okay. Well, hopefully the second question is answered and you have that information you want. I see a new question coming in from Rutger Riens. I noticed that both Apache Airflow and Apache Beam are used for job scheduling. Could you elaborate on what job types you prefer to use or what tool?
Yeah. Okay. So actually for job scheduling, we only use Airflow. We do use an Apache Beam job, which is being run it's a Dataflow job which uses Apache Beam. Basically, what we try to do is, of course, not overload sort of our Airflow cluster with all kinds of heavy computational jobs. So everything is scheduled from within Airflow. So Airflow tells Apache Beam to execute a certain job. Then that Apache Beam job is run somewhere else, and results are again stored in cloud storage. And then Airflow is of course then scheduling another job, which then loads it into the data warehouse on Snowflake. So the scheduling part is actually only done at the moment with Airflow.
Okay, clear. And another question from Kataba Saur. What is the role of the data security in the data processing operations?
Sorry,
can
I see you?
Of course. What is the role of the data security in the data processing operations?
I'm also, to be honest, I don't fully understand what is the question. Maybe I just, in general, what I can say about data security is that it links a bit to the right to be forgotten, of course. So With this setup, it's much more transparent. Of course, we also have Snowflake now in place, who have a lot of experience with these type of issues. We are aware of the fact that with this modular setup, data resides in sort of different areas. So we have also the data lake where we have storage buckets in place. So that's something where we need to take care of and be focused on that within this sort of these separate layers, that we make sure that everywhere in those layers we are aware of data security issues, basically. So it's indeed a fair question. I'm not sure if it answers the question, but it is top of our mind in a sense that we are aware of this fact, so to say. Yeah.
Okay, great. Thanks for answering that question. Next question coming in from Peter G again. Are you using cloud services rather than your own hardware service because it's cheaper or because it's easier? Or is it because it's more expensive but the cost is manageable?
Yeah, so it's a good one. I think it has to do with indeed the last part in his question. It's more manageable, especially also, and it also has to do with scale, of course, because we are a rapidly growing company. We have doubled our fleet every year, and it will be. Basically, our ambition is world domination, to put it bluntly. So that means a lot of new cities, a lot of new vehicles to be operating, and a lot of data, new data that's coming in, and a lot of increasement in use cases as well. To cope with that, you have Snowflake, you have cloud native solutions, basically, and indeed you're capable of managing those costs.
Yes. Okay, thanks, Dan. I think your answers are very clear. I hope, of course, for the viewers that their questions have been answered so far as well. Because of the time, I think it's good that we round it off with two last questions. All the other questions, of course, we can discuss them later, and our team will write them the answer down. So for the readers or for the people who have their last questions, feel free to ask them. They will be answered. Maybe not during this webinar, but after that, definitely. So a question from Jits Beumer. What has been the biggest learning point during the building of the new architecture? And what is the next step from now on looking at the architecture?
Yeah, good question. I think every one of our team might have a different answer, but for me, one big learning point was also in terms of planning and communication, so that's not like a technical answer. Maybe someone else has that, but for me, biggest learning point was we had some very how do you say it, tough deadlines to reach to have finished our data warehouse before that, because we were going live in different cities and stuff like that, and we wanted to be we wanted to have an environment which was capable of handling these amounts of data. In the meantime, we made some sort of pragmatic solutions to work with it, but our planning was first based on those deadlines, whereas we noticed at some point it's just not realistic anymore. Let's plan our work or plan based on what we can do. So we also got a new Scrum Master involved, and we were working in the Scrum Agile way, by the way. And then we just said, okay, well, it's not realistic to move the deadline for 1 or 2 weeks or 1 month. Now, looking at what we can do with the team, it will be moved. It's possible to make it in this amount of time. And for me, that was a big learning point. Just plan on. Everybody worked quite hard. You cannot do more than that. So of course you can work efficiently, try to improve your processes, and we're doing that. But just be realistic and communicate good to the rest of the company, because based on your communication, other people will also make decisions. So it's just really good to communicate this in a clear way and also in a realistic manner, I think. So for me, that was a big learning point.
Yeah, nice. And when it comes to where you want to go when looking at the architecture?
Yeah, no, very good question. Don't know if anyone wants to answer, but what I now find is it also depends on the use cases and the business cases for it. But what is now still, I would say, underdeveloped. It's also because we don't have yet a real cool use case for it. But it's like the real time part of our whole data warehouse architecture. So really being able to real time manage your data and make decisions and stuff like that. So for me, that would be like a really cool new challenge to make sure we have a professional environment to work with that.
Yeah.
It's just for me. But,
I think it's
Nice.
also maybe to add to that. Sorry.
No worries.
So there are a few topics indeed. So one of them is already described by Mace. Another one is, I think, data quality. It's always an ongoing thing everywhere when it comes to data analytics, but also for us. So we really focused on a new architecture, but after that, we really want to implement some more advanced data quality checks and pipelines there. So it's more about the about that part. I think in general about the Dataops. It's also a bit of a buzzword, but you know, your whole CI/CD around data architecture, basically, that's always we took it into account, of course, but when things get excited and you have your deadlines, it's always the easiest one to skip, basically. So that's also a topic that we will definitely touch upon. Yeah.
Nice. Well, thanks again for your time, everyone actually from Felyx, from Carolina, Lars, to Mace, and Dan. I enjoyed the presentation personally very much, and I think, you answered most of the questions. There's still a lot of questions coming in, and I also see a lot of thanks coming in. So also thanks from the viewers. And the other questions, let's discuss them later on so we can write the answers down so the viewers can read it afterwards. Again, thanks a lot for everyone, and see you next time.
Thanks for having us, Noel.
Yeah.
Yes.
Thanks for hosting.
Thanks, everyone.
Thanks, everyone. Bye-bye.
Bye.
Bye.